Hi everyone, and welcome to this video going over lesson 31, area of rectangles and triangles. To find the area means to find the total space taken up by a flat 2D shape. So what we're going to do is we're going to find how we measure the amount of space in rectangles, squares, and triangles. Now you've already probably gone over this in elementary school, but the area of a rectangle formula is length times width. Or I've also heard it called base times height. Which means we are going to take the length of the rectangle and multiply it by the width of the rectangle, and that'll tell us the amount of space in the rectangle, also known as the area. Now, a square is also a rectangle, so it follows the same formula, but if you think about it, since a square has all equal side lengths, if we were to multiply the length times the width, we would be multiplying the same number by itself. So another way of saying the area of a square formula is by saying the sides squared, because we are multiplying the same length by itself twice, which is the definition of squaring a number. So let's try practicing these formulas. In my first rectangle, I have a length of 6 kilometers and a width of 5.6 kilometers. So I'm going to multiply those two together. So I have area equals 6 kilometers times 5.6 kilometers. And just multiplying those together, I get 33.6. And notice how I am multiplying 2 kilometers together. Kilometers times kilometers will give me kilometers squared. So whenever you are finding area, your units will always be squared. So please keep that in mind. In number 2, I'm going to multiply 2 meters times 2.7 meters. And plugging this into a calculator, I will get 5.4 meters squared. In number 3, I have a square, because notice how the length and the width are 10.3 yards. So because I'm multiplying those two together, I can just say that this area is 10.3 yards squared. And that'll get me an area of 106.09 yards squared. And then again in number 4, I also have a square. So to find the area, I am going to square 7.3 yards. And this will give me an area of 53.29 yards squared. Now that we know how to find the area of rectangles and squares, this can help us find the area of composite figures. A composite figure is a two-dimensional shape made up of other two-dimensional shapes. So think about if I took a square and a rectangle and a triangle and I mushed them all into one shape, that would be a composite figure. And because a composite figure is made up of a bunch of two-dimensional shapes, I can break it up into those two-dimensional shapes that I know how to find the area of. For example, if you look at the shape in number 1, if I were to draw an imaginary line right there, notice how I formed 2 rectangles. And a rectangle is a shape that I know how to find the area of. So now I can find the area of those 2 rectangles separately and then add them together to get the area of the entire composite figure. So when you're doing these problems, please pay extra close attention to the labels. 8 is going to be the length of this rectangle that I'm going to outline in blue. And 3 is going to be the width. So I'm going to do 8 times 3, which will give me 24 for that area. And then I need to find the area of this red rectangle. And I know the length is 5. but I need to figure out the width. And please be careful. Notice how 11 is the width of this entire side. All I want is this little section. And I know that the majority of that side is 8 units. So all I have to do is subtract 8 from 11 to find out how much is left over. So 11 minus 8 is going to give me 3. And so to find the area of that red rectangle, I just have to multiply 5 times 3, which would be 15. And then to find the area of the entire composite figure, I'm going to add 15 and 24 together, which would give me 39. And I'm going to say units squared since I don't have any other units given to me. For number 2, I want to find the area of just the shaded section. So which means I need to find the area of the entire rectangle and remove that white rectangle in the middle. So to find the area of the entire rectangle, I'm going to multiply 12 and 24 together. So 12 times 24 will give me 288 units squared. And then to find the area of that inside rectangle, I'm going to multiply 4 times 8, which will give me 32. And I need to remove that because I don't want to count that in my total area. So I'm going to do 288 minus 32, which will give me 256 units squared. I'm going to look at number 4 first before I look at number 3. So looking at number 4, notice how I have these little tick marks. In first semester, we talked about how tick marks indicate congruence, which means all of those lengths are the same. And if all of those lengths have to add up to 27, I'm going to divide 27 by 3 to find out what each of those are. So 27 divided by 3 will give me 9 for each of those lengths. And similarly, I have 2 tick marks on these vertical side lengths that all are supposed to add up to 18. And so 18 divided by 3 will give me 6 for each of those lengths. And in order to find the area of this composite figure, I need to break it up into shapes that I know how to find the area of. So I'm going to draw some imaginary lines to create 3 separate rectangles. For this first rectangle, I'm going to do 9 times 6, which will give me 54 units squared. And remember, when you do these problems, rectangles have equal opposite sides. So if this left side of the rectangle is 6 units, then this side will also be 6 units. So in total, this entire side will be 12 units long. So in order to find the area of that middle rectangle, I have to multiply 9 times 12, which will give me 108. And then for that final rectangle, I have to do 9 times 18, which will give me 162. And now that I know the area of each piece, all I have to do is add them together. 54 plus 108 plus 162 will give me 324 units squared. And then last one, looking at number 3, once again, I want to find the area of just the shaded region. And if you notice, that shaded region is about half of the entire rectangle. So if I were to find the area of the rectangle as normal, length times width, so 5 times 14, I can find the area of just that shaded section by dividing the total area in half. And so 5 times 14 is 70, and dividing by 2 will give me 35 units squared. And I want you to notice something. Notice how the shape of this shaded section looks like a triangle. What we just did was discover what the area formula is for a triangle. Because if we are to split a rectangle in half or a square in half, we create a triangle. And so in order to find the area of a triangle, we do base times height, but then divide it by 2. Because we don't want to find the area of the entire rectangle, we just want to take half of it to get that triangle shape. So the area of a triangle formula is base times height divided by 2. And it's because if we are given a triangle with a specific base and height, we know that this is just half of a rectangle with that same base and height. And so by dividing by 2, we are just finding the area of the triangle portion. Now the tricky part about these is we have to determine which lengths to use for the base and the height. The height has to be perpendicular to the base, and it has to go all the way to the top of the triangle, to the base of the triangle, and make a 90-degree angle. So in this first one, it looks like my base is going to be 14. And notice how this line right here goes from the top of the triangle to the base of the triangle and makes a 90-degree angle, which tells us this line is straight up and down and accurately represents the height of this triangle. So that means the height of the triangle is 3 units. And now I'm ready to plug this into my area of a triangle formula. So I'm going to have 3 times 14 and then divided by 2, which will give me 21 units squared. Looking at number 2, I know that this flat length of 7 looks like it's going to be the base, but if 7 was the base, we would need to know the length of this imaginary line that is perpendicular to the base and goes to the top of the triangle. But we don't know what that length is, so we aren't going to use 7 as our base, and instead we should use 6 as our base. Because notice if 6 is our base, we do know the length from the top of the triangle to the base of the triangle that is perpendicular to the base, which tells me we are going to use 6.8 and 6. So the area of this triangle will be 6.8 times 6 divided by 2, which will give me an area of 20.4 units squared. And lastly, number 3, notice how it's only this portion that is solid. And it's because this is the triangle that I'm trying to find the area of. This dashed section on the outside represents my height. And sometimes the height line is outside of the triangle, depending on how the triangle is drawn. Because notice, if this is the top of my triangle, and this is my base down below, the only way to make a perpendicular line is for this line to be outside of the triangle. So in this case, my base is just 6, because notice I only want the base of the triangle I'm trying to find the area of, and my height is 5, because that is the length of the side that is perpendicular to my base, and that goes from the very top of the triangle to the base of the triangle. So my area will be 5 times 6 divided by 2. 5 times 6 is 30 divided by 2, which will give me 15 units squared. So please keep in mind, we want the height of our triangle to go from the top of the triangle to the base of the triangle and make a 90-degree angle. And sometimes this height line is outside of our triangle if our triangle is a little skewed, or this height line could be inside the triangle like we saw in number 2. So to make sure you understand this, I have one more problem for you. Mario, Raquel, and Jocelyn are arguing about where the height is for the triangle at right. The 3 have written their names along the part they think should be the height. Determine which person is correct. Explain why the one you chose is correct and why the other 2 are incorrect. So once again, focus on the part of the triangle that's solid, because it's the solid triangle that I'm trying to find the area of, and anything dashed is imaginary outside of the triangle. So let's determine who was correct for this height line. So let's say that this bottom side is the base of my triangle. We are looking for a line that goes from the top of the triangle to the base of the triangle, and that is perpendicular to the base. So looking at Mario's line is perpendicular to the base, but it doesn't go to the very top of the triangle. It's only about halfway through. So it's not going to be Mario. Looking at Raquel's line is slanted and not perpendicular to the base, so it's not going to be Raquel. But Jocelyn's line does go to the very top of the triangle and down to the base, pretending that the base is extended a little bit, and is perpendicular to the base. So in this case, Jocelyn is correct because her line accurately reflects the height of the triangle and is perpendicular to the base. And so those are our two area formulas for rectangles and triangles. I hope that you can use these when you're finding areas of composite figures. And please be careful about which lengths you use for the base and the height when dealing with triangles. Please let me know if you have any questions, and I will see you in class.